The former limits the frequency range while the latter limits the dynamic voltage. As I said, former means the parasitic capacitance will limit the high frequency operation of resistor. Latter means it's going to be the voltage coefficient will have an effect on the range of voltages which the system can operate. So it will ensure, it will make that you cannot use these resistors for a wide range of applications. It will be having lot of limitations. So additional care must be taken to avoid forward biasing either end resistance. So forward biasing will result in heavy current flow. Then the ultimate purpose of fabricating a resistor is going to be lost. Okay. So the source drain regions are formed to be very shallow, heavily doped, and I'm going to use silicited poly, so leading to a very low temperature coefficient. So I'm going to fabricate the resistance from the source drain region by proper fabrication methodology. So it is going to be very shallow, means I'm going to make it very, very thin, not exceeding 200 to 300 nanometers, but heavily doped and mostly silicited poly I'm going to use. And the temperature coefficient what I get is 500 to 1000 ppm per degree Celsius. So I can also be use wells for high value resistance, and the resistivities are going to be very high in the well. So I can create a well type structure while fabricating, and I can use that for creating a high resistance effect. But unfortunately, when you have a well, the para capacitive effect will be there. So the parasitics are going to be dominant for well type resistors. So the resulting resistance will have poor tolerance. 50 to 80% is very high, or I can say the resistor is going to be completely useless, and temperature coefficient is also very large. The temperature coefficient will say that if the temperature is increasing, how quickly the resistance value is also increasing. Previously we had 200 to 500 to 1000. It is decent, but now it has crossed to 5000. So 1 degree temperature rise, your resistance value will shoot up. So the tolerance will also be very high, and all points will be against you. So in a circuit, this resistance cannot work as it is expected. So well resistors, you have to be taking utmost care to fabricate them. So sometimes you can replace a MOS transistor as a resistor. That is done nowadays. MOS metal oxide semiconductor device can work as a voltage variable resistor. That is a very default property of a MOS. So I can replace resistance with MOS transistor also.